Welcome friends, I am Tanmay and welcome you all in my channel Chemistry of Molecules. So this is a continuation of Pinacol-Pinacolone rearrangement session. Today we are going to explain about Pinacol-Pinacolone rearrangement for unsymmetrical substances. Okay, so what we are going to discuss about? Unsymmetrical. So previously we have discussed about symmetrical substrates. So now we'll unsymmetrical substance means question which side will undergo carbocation formation and rearrange. So there's a confusion. So this video will help you to improve your knowledge such that you can handle those conformations logically. Okay, I repeat, you'll be able to handle those conformations logically. So, but before going to this discussion, I suggest you please go through the first video about Pinacol-Pinacolone rearrangement, mechanism and basic concept, and second you go to the examples. It will help you to strengthen your understanding about the basic concept and its utilization via the examples video. Okay, after that you come, then it will be helpful for you, otherwise it may not provide maximum benefit to you. Okay, so let's start. So what happens? You can see the same reagent under cold sulfuric acid condition provides one product, and another case acetic acid sulfuric acid claritic amount produces another product. And here I have written KCP and TCP. What is KCP? KCP is kinetically controlled product. Okay, and TCP is thermodynamically controlled product. Okay, fine. So this is the KCP and TCP. So now the thing is that here KCP plays a role, and here here TCP means thermodynamics, here kinetics, thermodynamics. So from kinetic point of view, what is the kinetics? Actually kinetics is mainly dealing with the collision. Okay, so actually here this sulfuric acid produces proton. So what will be the collision of this hydroxyl and this? Logically both possible, but you see there are some bright bulkness and second after. So what is possible? Let's draw the two carbocation. So CH3. So if protonation happens, on this, then carbocation will be generated. So the carbocation will be this. So these will be intact. And if protonation happens this, then the carbocation will be generated here. This will be intact. Now, from kinetics means low temperature and collision. So what will be the product under this? That's why cold is written. Low temperature kinetic, and if you increase the temperature, then there will be thermodynamics will start to play a role. Okay. So first initial reaction, there will see here carbocation is more stable. Why? Because this carbocation is benzylic and this is tertiary butyl. Both are means this is also a tertiary and this is also a tertiary. No problem. But here the substituents are phenyl. Means what do I mean? So this resonance stabilization possible for this carbocation, this tertiary as well as benzylic. This is only tertiary. So this is more stable. Consequently, this will produce, and if this produces, then what will happen? This will push its electron and methyl will migrate. So ultimately, one side will be diphenyl methyl and another side will be this methyl along with this ketone. So this is diphenyl methyl, and you can see that another side is ketone methyl. So we have explained how this is happening. Now see here. In terms of acetic acid and catalytic amount of sulfuric acid, another thing is happening. So question, how this is happening? So this is happening, it's true. So this means this is leaving. So carbocation is generating here, then phenyl is migrating, then only this is possible. It's true. But how to understand this factor? You see, you have understood ester hydrolysis. You have read. Okay, so ester preparation. I not say hydrolysis. Ester preparation from acid and alcohol. Just consider that concept. This is an alcohol diion. So one among these two one will act, and second this is acetic anhydride. Now how this reaction happens? If it is acetic anhydride, its structure is, this is COCH3 OCOCH3. Fine. So catalytic amount of sulfuric acid is given and this. So chances are that sulfuric acid may protonate this or this, but since acetic anhydride generally taken is excess, so chances that they will be protonated. Second point, that if you consider here alcohol, this is nothing but an alcohol, okay, is going to protonate, basicity of alcohol, and this is anhydride. What do I mean? This anhydride has, means it can due to it has a resonance. What do I mean that resonance? So OCH3, this OCH3, so this oxygen can push its electron on this. So what is the conclusion of this story? Means ultimately what will produce? This is a double bond and here O minus. So what is the conclusion of this discussion? That the electron density on this is more. So protonation probability on this oxygen is more. Fine. So okay, now what happens? So protonation will happen. We have understood that this acetic anhydride will not remain in this stage. In presence of sulfuric acid, it will remain in this stage. Delta plus. Now both alcohol can go and attack. Okay, both alcohol. What do I mean? Means this is OH, this is OH. Let's consider this is methyl, and this is BH. So both can attack, but we know that right now this is an electrophile. This is a electrophile, means electrophilic center. This is electrophilic, and alcohol is nucleophilic. And bulkness of the nucleophile attacks during this, and actually there is a nucleophilic acyl substitution. Okay. So what happens? If this hydroxyl attacks, means what I am saying, if this attacks, then the bulkness of these two phenyl will matter. But if this attacks, means if this attacks this OH, then bulkness is lesser in case of methyl compared to phenyl. I all repeat, compared to phenyl, methyl is less bulky. So this oxygen will attack. Okay, so this oxygen will attack, it will go, again it will push back, it will leave. So ultimately what it will produce? So ultimately it will produce this OCOCH3. Okay, so ester formation or acetylation will happen on this oxygen. So right now this oxygen become a good leaving group. So if it is become selectively, means by synthetic design we make it a good leaving group. So if it leaves this carbocation, so if this OAC is a good leaving group, so if leaves, then carbocation will be generated here, then the process will follow here. Exactly happening this. So what happens? This oxygen pushes this electron and phenyl is forced to migrate. It do not have any chance because this oxygen is converted into a good leaving group. So phenyl have to migrate. Okay, through this cation, means carbocation formation on this center selectively. So if it migrates, so one carbon will be dimethyl attached with phenyl and another will be phenyl attached with ketone. See, this is so in this way, after phenyl migration, this will be the result. So phenyl will migrate, it will leave, and ultimately this will be the product. So this is the basic concept about this thermodynamic control versus kinetic control. So I believe you have understood this. It is a very important concept, and if you understood, there is a very less chance of mistake. Okay, fine. Now discuss another example. This is also not a symmetrical one. Okay, so what happens if you provide sulfuric acid? Here some contradiction is there, that these versus these, which will be and when, but here no contradiction. What happens in presence of sulfuric, only sulfuric acid case I am dealing, that in presence of sulfuric acid what happens? That protonation possible for both, but which center will be protonate, which results in more stable carbocation, and carbocation is more stable at this center because it's a tertiary, so protonation will occur here to produce this dimethyl. So this carbocation and this is CH and this OH. So same concept, this push hydride will migrate and ultimately it will produce this dimethyl acetaldehyde. This is a unique method for the preparation of dimethyl acetaldehyde, and this molecule is very unique because it do not undergo aldol condensation because of the bulkness. Okay, so I have explained that factor in previous videos. So this is the uniqueness of this molecule. Okay, fine. So we have discussed about this. Similarly, under similar reaction condition, what happens? Instead of methyl, if we take phenyl, same product will be obtained. So this product will be PH, CH, aldehyde. Fine. But the problem or confusion arises when it kept for long time. Okay, and actually this is a KCP, kinetically controlled product. Okay, and this is, it produces the final product which is TCP, thermodynamically controlled product. How this is happening? So if longer time is kept into the reaction medium, so what happens? These will produce another, means this is PH, H. So this oxygen will be protonated. Protonated means this hydrogen, this plus. So what will be the confusion? So after that it will, and if it produce means carbocation will be come from here to here. Now it is true that phenyl hydride will migrate. So if hydride migrate, that will be similar product. So no conclusion, but we are getting this, means at this condition, prolonged time, this phenyl is migrating. Okay, I know it's little late, but this is migrating. Reason is, see, in one carbon, 1, 2 phenyl, another aldehyde, this hydrogen, this is more bulky, less stable, but this product is less stable. I will explain how this is. So what phenyl is migrating here? So it produced this PH, H, and carbocation will be generated here. Fine. So this, and see here one hydrogen, one phenyl, and one OH. Okay, fine. So now similar condition like Pinacol-Pinacolone rearrangement, hydroxyl group is there along with that neighboring group, means this is 1, this is 2. Carbocation is there and it can push its electron. So there is a means competition. If it push, who will migrate? If phenyl migrates, that will be the same product. But as we know that hydride has a greater migratory aptitude, so hydride will migrate. What do I mean? These will migrate. And if this migrates, then what will be the product? This will be a double bond, will be here, that will be attached to phenyl. Another thing, hydride is migrating. Previously one hydrogen is there, one hydrogen is coming, so CH2 and PH. Now you may ask the question that in first case phenyl is migrating, in second case hydride. Why? Because as I told, I am repeating it again, explanation. Because if hydride migrates, it will migrate. I am not saying it will not migrate. It will migrate, but that will be resulting in the same product. So effectively, from our point of view, that we are not getting anything new, but reaction is happening. But if this happens, we are getting a different product. And actually, after reaction means longer reaction time, we are getting this. So that means that this is happening significantly. That's why this is producing, but since there is a competition, that's why longer time needed, and this is thermodynamically controlled product. Okay. So let's so this factor, so this strategy could be utilized for the preparation, for the proof that Pinacol-Pinacolone is intramolecular. What do I mean? I mean that you can take a mixture of Pinacol-Pinacolone rearrangement. Okay, I'll explain. Let's continue the discussion. Here you can see that Pinacol-Pinacolone rearrangement is a intramolecular, not intramolecular. Okay, it is a intramolecular. That factor could be proved by this crossover experiment. What do I mean? That crossover experiment means mix two and do the same reaction, do the reaction at the same port and see. What here you can see, this is a diphenyl methyl in this, and I have explained that in case of cold sulfuric acid only thermodynamically, but if temperature, reaction temperature increases, so kinetic thermodynamic, there will be a mixture. So what is expected? First, that if methyl migrates, then this will be, and if phenyl migrates, then this will be. pH migrates, let's say pH mig, and this is methyl mig, means migrate, mig means migrate. So this will, similarly here if ethyl migrates, so Et mig, and here phenyl migrates, so pH mig. This is the simple thing, that if you take these or these reagents separately, under this condition you will get two product mixture. It's a thermodynamic product as I given heat. Okay, so this fine. But if this reaction is not intramolecular, not, I am saying, if let's consider, it is not true, but let's consider, if it is not intramolecular reaction, then we could have some ethyl-methyl mixture. What I am saying, that this means 4 possible, I am just written 2, so this mixture possible. So ethyl could be here, methyl is here, or ethyl is here, methyl is here, if it is. So these cross products, okay, expected to possible, but this is not getting. This cross product we are not getting. Okay. So means, and how this cross product possible? We have to break this, but this breakage is not happens. That's why we don't get any cross product. And another thing, it's intramolecular because what I am saying, because so if we want to say this, for example, let's consider that carbocation is produced here. We are saying that it is intramolecular, means this phenyl will migrate. Sorry, I made 4, I told 4 will not possible, 2 possible. So we are considering this phenyl will migrate. Okay, fine. Instead of that phenyl, this methyl if migrates. Okay, that could be one product. Means okay. So that could be one which is not written here. Let's consider from another direction. I am not written. Let's consider that what is written. So if these migrates, in both case this is possible. Means in both case this is possible. Carbocation here, carbocation here. Okay. So if that migrates, one chance is that ethyl is there, fine. So instead of this ethyl, this methyl can migrate. Means if it is intramolecular, then this mixture of product will be obtained. So if it is, then there will be this methyl is migrating. So here, what will be the product? So if methyl is migrating, then here there will be pH methyl, and here OH ET, fine. And after this migration, means if it migrates, then there will be no carbocation. This is neutral, this is carbocation. So what will be the fate of this? So this is pH, this is pH. This migration is this assisted. So this is OH, this is double bond O, double bond CH3. Fine. So next stage, what will happen? These will eliminate. Carbocation here produced, and that time you can see this can push and this ethyl can come here. So what will be the product? One side is pH ethyl, this, and one side is pH methyl, this, and the other side is corresponding methyl or ethyl opposite one. So in this way cross product possible, but since it is not intermolecular, it is intramolecular, that's why we will not get any of this cross product. We will get this. So this example proves that this Pinacol-Pinacolone rearrangement is intramolecular, and that is based on this unsymmetrical substrate. Okay, fine. So this is the end of discussion. I believe you have learned a lot from this. So today we have discussed about this mainly unsymmetrical Pinacol-Pinacolone rearrangement, which under different condition, for example thermodynamically controlled condition or kinetically controlled condition, what the product is produced, and I have explained mechanistically how this is produced. Okay, so this is the end of the discussion. If you like my teaching, please support my channel and you can support this channel by first subscribing my channel Chemistry, the Mystery of Molecule, and share this video among your friends so that many people could be benefited from my effort. And finally, please press the bell icon to get the notification of every single video I upload. And most importantly, I am trying to upload videos about basic chemistry which will help you to understand it, and if you understand basic knowledge properly, I believe it will be extremely beneficial for you to crack any difficult problem or any uncommon problem come in your exam. So learn in deep, and I will try to help my best. So all the best, stay happy, stay cool, see you in my next video.